You did it to me again. Last week you walked me right up to the door, flung it open, and left me squinting into the dark with the strangest promise you've made all season. 8 nights of us shoving and pulling the world into moving, learning to see every force there is, even the ghost ones that aren't there, the ones that flung me against the merry-go-round rail with no hand anywhere behind them. And then, at the door, you tell me to set my hands in my lap and put the whole idea down. Just like that.
I did say that, word for word, and I meant it. I've been looking forward to this one all week.
You said it just so too. Set our hands in our laps and watch it choose. I have not stopped turning those 2 words over all week. You promised the whole of mechanics, every orbit, every pendulum, every top of this whole season, done without drawing a single force. But force is mechanics. Push a thing, it moves. That's the game. So I've spent 7 days deciding you were bluffing, and I've come to call it.
I was counting on you to come in swinging. You wouldn't be you otherwise. And I'm not going to argue the case at you. I'm going to hand you one picture, the plainest picture in the world, and let it do the arguing for me. You toss a ball gently across the room, and it arcs, up, over, and down into a waiting hand.
I can see it. That one smooth, lazy curve through the air. Ball goes up, ball comes down. I could draw it with my eyes shut. It is about the least mysterious thing you could possibly have reached for, which, knowing you, means it is about to become the most mysterious thing in the room.
The most mysterious thing in the room. Because here's how we've built that arc for 8 nights running. You stand at the start, the ball in your hand, and you know 2 things about it. Where it is and how fast it's going. Only those 2. The state of the thing. And you hand them to the clock, and the clock grinds out the future.
That's the first night. You turn the crank, force equals mass times acceleration, the beating engine of the whole subject, and it walks you forward 1 instant. New place, new speed. Then you turn it again. Beads on a string, 1 tick at a time. Always local, always right now. The ball, this instant, being told which way to bend next, and next, and next.
And the whole arc built up out of those tiny nudges. That's the clockwork, wound and ticking. And it works. More than works. That crank sent probes to the planets, we said on the first night. So I've nothing against it. It's true at every tick. But tonight I want to climb up and watch that same arc from a higher window.
A higher window? Meaning what, exactly? I stop turning the crank?
You stop building it moment by moment. Step all the way back and take in the whole journey at once. Start to finish, the entire trip hanging in the air, complete. The ball leaves your hand here. It lands over there. And you ask a different question. Not, which way does it bend next? The crank's question. Ask, of all the ways it could have crossed, why that one?
What do you mean, some other? It goes the way it goes. There isn't another. The ball does the arc. That's the arc it does. There's no menu it's ordering off.
Isn't there? Look at all the ways it could have made the same trip. Same start, same finish, same stretch of time to do it in. It could have shot up steep and dropped like a stone. It could have skimmed low and level and lunged upward at the very end. It could have looped, dithered, sailed out the window and swung back. It could have crawled across dead slow, or bolted the first half and idled the second. Every one of them leaves your hand and arrives in the catch. Nothing in the rules forbids a single one.
It could have, but it didn't. Those are things I could draw on paper, not things that happen. You're filling my nice, clean living room with arcs that no ball has ever once flown.
Draw them all anyway. Every route from the hand to the hand. A whole ghostly fan of arcs, thousands of them layered in the air like tracings on tracing paper. Every arc the ball could conceivably draw. And out of that entire fan, the world lights up precisely one, and lets the rest stay ghosts. Tonight is about why.
All right, that's a lovely, eerie image. the fan of ghost arcs all hanging there together. But most of them are nonsense. The ball is not going to loop the loop across my living room. Obviously, it takes the sensible one. The rest are just lines I drew for the sake of the argument.
They're lines you drew. But hold on to why the world snubs them, because that is the argument. Here's the claim you came to fight, said plainly. There's a single number you can pin onto each ghost arc, one number for a whole path. And the ball flies the arc that makes that number come out as small as it will go.
No, stop, listen to what you said. For the ball to pick the smallest, it has to have checked the others. It has to have sized up every lunatic detour on the menu, quietly priced each one, and then gone, that one's the bargain, I'll take it. Before it's even left my hand, that is a preposterous amount of shopping for a rock to be doing on its way across a room.
That's fair to Ballcat, and I won't smooth it over. Keep it in your fist all night, because we come back to it at the very end, and the answer is stranger than your complaint is. For now, hold your fire and grant me the arithmetic, so we can find out what this number even is.
And there's worse than the shopping while I'm complaining. You're asking me to swallow that the ball commits to a whole path at once. All of it, chosen in one stroke, start to finish. But a path isn't chosen, it's built, step by step. The ball doesn't know where it'll be at the end while it's still leaving my hand. Nothing picks its whole future in a single go.
Plant your flag right there. A path can't be chosen all at once. I want you to feel that one very firmly, because it is the flag I mean to walk out from under you before the night is done. So plant it and let's build the number. And to build it, I don't need a single force. I need two things you already own from one of the old nights.
From the landscape night, I'd bet, by the look on you, the hills and valleys. The ones you can literally draw, that a moving thing rolls around inside. Fast down in the valleys, slow up on the hills. I liked that night. Nobody flung me off a merry-go-round on that one.
That night. Two energies lived in that landscape, and those two are my whole toolkit tonight. The first is the energy of motion. Motion energy, the having speed. A thing carries it simply because it's moving, and the faster it goes, the more of it it's got. The motion you can see. And the second is the energy of position. Place energy, the fall it's got waiting inside it, set by where it stands on the landscape.
High up on a hill, a great deal held in reserve. Down in a valley, next to none. Motion and place, the speed it's got and the height it's banked. And the thing I finally made my peace with that night was that those two are forever trading. Ball climbs, motion pours into place, it slows. Ball drops, place pours back into motion, it speeds up. The two pockets, swapping the whole way.
The two pockets. And the keeper line you underlined that night was that the sum of them holds still. Motion plus place, level clean across the landscape, never budging. Hold that, because it's about to make trouble in the nicest way. And notice the one property both energies share, the thing that sets them apart from everything else we've handled all season. They're numbers. Plain numbers, not arrows.
Not arrows? As opposed to a force, you mean? The thing I had to chase around by which way it pointed.
As opposed to a force. A force always came at you as an arrow. You had to bookkeep which way it aimed, chase it component by component across the page. Motion energy and place energy don't aim anywhere. They've got no which way buried inside. They only ever tell you how much. A size, never a direction.
Right. Energy knows how fast. It never knows which way. You drilled that in. So I've got two plain sizes riding on the ball at every instant of its flight, and not one direction to keep track of. That already sounds easier than a page full of arrows. Now, what on earth do I do with the pair of them?
Now the strange move. You'd think, to score a path, you'd add them. Motion plus place. The total, the thing that holds still and never budges, the quantity you underlined twice. That's the natural guess, and it's wrong. You don't add them, you subtract. At every instant along the arc, you take the motion energy and take away the place energy. Motion energy minus place energy, never their sum. And that difference, moment by moment, has a name. The Lagrangian.
No, hold on. Subtract? Last week, the whole revelation, the thing I underlined, was that the two of them ADD, and the sum is the one quantity in all the world that never moves. Energy adds. That's the law I marched out of here holding. And now, first thing you do, you grab one of them and jam a minus in front of it. Why in the world would I subtract the place energy? What did place energy ever do to you?
Ah, there's more to hold than credit, and it's the minus itself doing the holding. Remember the claim you came to fight. The ball flies the arc that makes this number as small as it'll go. So go hunting for smallness. Where does the ball find it? Look hard at that minus. It's the place energy being subtracted. The higher the ball rides, the more place energy it's banked, and the more of it there is to take away. Subtract a bigger thing, and the whole score sinks. So the minus pays the ball to climb, and there's your answer to why it won't just creep along the floor. Down low, there's next to no place energy worth subtracting, so hugging the ground keeps the score stubbornly large. The minus is the very thing that lifts the ball off the floor and bends it up into an arc.
Now, hang on, you've overshot. If the minus pays it to climb, then the ball's best move is to bolt straight for the ceiling, get as high as it possibly can, and hang up there the whole crossing, banking place energy by the armful. That isn't the throw I know. That's a ball trying to leave through the roof.
And there's the other jaw of the trap. Climbing isn't free. The trip's on a clock. To rise up high and still land in the waiting hand on time, the ball has to move quickly, and moving quickly piles motion energy up fast. And motion energy is the half wearing the plus sign, the half that shoves the score right back up. So a mad dash for the ceiling burns so much motion energy on the way that it wrecks the very bargain it was chasing. The ball can't have its height for free. It pays for the climb in speed, and speed runs the tab back up.
So it's pulled two ways at once. The minus is coaxing it upward. Go high, bank the height, sink the score. And the plus is hauling it back. Climb too hard, and the motion energy you burn undoes everything you gained. It can't hug the floor, and it can't rocket to the roof.
So it does the only thing left. It strikes the truce. It climbs, but gently, spending just enough motion energy to reach up where the place energy is fat and worth subtracting, and not a scrap more. Rise enough to bank a good, deep dip in the score up high. Measure the height from your hand, and up near the top, that difference can go as small as it ever gets, even dipping below zero, but never so frantically that the motion energy blows the whole budget. Hold that balance at every instant of the crossing, and the curve it carves is the exact arc you throw. The parabola. That balance is the parabola, and it's the minus that forced the trade.
Oh, now I've got it. And I'm half sorry I fought you. The sum, the total, the thing that holds still. Of course it can't score a path. Same number at the floor, same number at the ceiling. It rewards nothing, it takes no side, it just sits there. It's the minus that gives the ball something to want, a reason to climb and a reason not to thrash. Subtract, and suddenly the score has an opinion. So that's what place energy ever did to me. It's the only reason the ball ever bothers to leave the floor at all.
That's exactly it. The minus is what makes the score care. And when you want it airtight, past all gut feel, the proof is still the one we're marching toward. Subtract, and the whole machine hands you Newton back. Add, and it hands you nonsense. But you felt the why now, and that's yours to keep. So hold your live number, the Lagrangian, one value at each instant, motion take away place, riding up and down the whole flight.
All right. And I've stopped resenting the minus, which I did not expect tonight. But one instant's number is still not a whole path. You said score the whole arc. How do I climb from a single tick to the entire journey?
You add up the ticks. Picture a stopwatch running the whole flight, and at every tick you jot down that difference. Motion energy, take away place energy. The value right then. Walk the ball along one arc, the real one or any ghost, jotting at every tick, all the way from the hand to the hand. Then pour the whole long column of numbers into a single sum. And that grand total for the complete trip has its own name. The action. One number standing in for one entire path.
The action. So that's the number on the ghost arc. Every arc in that hanging fan, the sensible one, the loop, the scenic detour over the mountains, each carries its own action. Each path walks around with a price tag stitched to it, and the name of the price is the action.
Every path its own price, and you can already feel which arcs come dear. Take your loop, the ball tearing around a wild extra circle on its way across the room. All that furious racing piles up motion energy, instant after instant, poured into the sum, so its action runs up enormous. The frantic paths are the expensive ones. The bill is steep for drama. Now the claim, as sharply as I can put it. Out of the whole fan, the arc the ball truly flies, the one the world lights up and keeps, is the arc whose action comes out smallest. Pin the two ends, sweep your eye across every path between them, and the true one is the one with the least action.
So the price isn't the minutes it takes, it's the fuss it kicks up. A path that thrashes around, spending motion energy like water the whole way, racks up a monstrous total. And the calm, sensible arc keeps the total modest. That's why the bargain always looks so reasonable. It's the one that makes the least fuss, not the one that gets there quickest.
The least fuss, not the quickest. Hold that distinction, it saves you later. The bargain is calm, not fast.
Least action. There's a grandeur to the phrase, I'll give you that. It sounds like a law you'd carve over a door.
There's a grown-up name carved over that door. Hamilton's principle. But least action is the one that sticks to the ribs. Now, you've gone quiet, which means you're loading something up.
I am, because you left a door open. If the real path is the one that makes this total smallest, least of anything, then I know that word. Least, smallest, cheap. So it's the fastest way across, isn't it? Quickest route, shortest trip. The ball's in a hurry and it's grabbing the express lane. Least action means least effort means fastest. Go on, tell me I've nailed it.
You've grabbed a cousin of it, and I'm glad you reached, because it lets me fence the cousin off before it bites you. There is a least something principle about the fastest route, but it belongs to light, not to your ball. A ray of light crossing from air into glass bends, and the path it bends onto is the one it can run in the least time. A real principle, older than tonight's, and Fermat's the name on it. Least time. Light really is the thing in a hurry. It hunts the quickest way through, and that's exactly why it kinks as it dives into the glass. Beautiful and old, and a different rule from ours.
But my ball isn't a ray of light. It's a lump of matter arcing across a room.
And your ball is not racing a clock. Least action is not least time. The ball is not hurrying, and it's not on the express lane. The thing it makes small is that summed-up difference, not the minutes on the trip. Cousins, the two principles, don't let them marry.
Good, I'll keep them apart. Light minimizes time. My ball minimizes this other thing, the action. But now I've got a fresh bone, and it's about the word least itself. Smallest of the whole fan? The ball scanned every arc in creation and found the rock-bottom cheapest. That's my shopping problem all over again. And honestly, it's worse now.
Here's where I owe you a correction on my own word, because I've been saying least, and it isn't quite the true one. The honest word is stationary. Picture the action as a height, and every possible arc as a spot on some vast rolling terrain. Each arc's action is how high the ground sits at its spot. The true path does not have to sit at the lowest point on all that terrain. It sits where the ground has gone flat.
Flat, not lowest, flat. Say what you mean by flat, because those are different things.
Nudge the path a hair in any direction, and the action doesn't drop and doesn't climb. Not to the first tiny bit. It's level underfoot. Most of the time that flat spot is a little valley floor, a genuine least. But flat is the real condition, not lowest. That's what least action actually means, and its honest name is stationary action.
So, least action is a bit of a sales slogan then. The true rule is the path where the total goes flat, where jiggling it doesn't change the price. And you said, most of the time a valley floor with a little wince, meaning sometimes it isn't even a valley.
Sometimes it isn't. For a short hop, the flat spot really is a bottom, smallest all around, an honest least. But let the journey run long enough, and the flat spot can be a saddle. Flat underfoot, yet with the ground falling away in some directions and rising in others. A least along some wiggles, a most along others. Still flat, still stationary, still the one true path.
So I should never quite trust that it's the rock bottom cheapest, it's the flat one, and least is just the friendly nickname for the usual case. Friendly name, least action. True name, stationary action. I'll hold both.
Hold both. That's the whole rule.
Then let me say the whole shape back, because it's assembled into something while you were talking, and I want to hear whether it holds together. I've got a start and a finish, pinned. I've got the whole fan of arcs between them, every route the ball could dream up. On each arc I walk along summing motion energy minus place energy, instant by instant, and that sum is the arc's action. And the arc the world picks is the one where that sum sits flat.
Where jiggling the path leaves the price unchanged. Go on. Say the part that startled you.
The part that startled me is that nowhere in any of that is there a force. Not one arrow, just two energies, a subtraction, a long sum, and find the flat one. That's a whole different machine from the crank.
A whole different machine, from the hand to the hand, and not one arrow in it. And I can feel the objection you're too polite to lead with, so let me say it for you. This is all very elegant, and so what? If it only ever coughs up the same arc the crank was already going to grind, it's a lovely painting of a thing you could do already.
That is precisely the objection I was too polite to lead with, thank you. Why would a sane person trade the trusty crank, the thing that flew us to the planets, for a fan of ghosts and a hunt for a flat spot?
Two answers, and the first is the one you need first. You don't even believe it gives the right arc yet, do you? Not really.
I don't. I'll be honest. I don't yet believe this flat spot business spits out the same arc my crank does. It's a pretty story. Prove they land in the same hand.
Then watch what falls out. Take the rule. Pin the two ends. Demand the action come out stationary, flat for every little wiggle of the path in between. That demand is a piece of machinery. You can turn a handle on it and ask, what must an arc be like so that jiggling it never changes its action? And an equation drops out the far end. One equation forced into being by the flatness alone. And that equation, letter for letter, is mass times acceleration equals force. It is Newton.
Wait, say that slower, because I think the floor just shifted under me. You start from something that names no forces at all. Two energies, a subtraction, a sum, make it flat, and out the far side, with no force having gone in, drops the exact force law I've been cranking for 8 solid nights? The whole engine?
The whole engine, entire. You didn't feed Newton in anywhere. No force, no arrow, no push crossed the threshold. You fed in two energies and a demand for flatness, and Newton walked out the far side under his own steam, which is either a coincidence of staggering size or a quiet hint that the force law was never the bedrock at all. that it was standing on something plainer all along.
Mass times acceleration comes out the back as a consequence of asking for a flat total. That isn't a new law at all. That's my law. Wearing a disguise the whole time.
Let's make sure you believe it, not just hear it. Test it on the simplest case there is. A ball with nothing pulling on it at all. No landscape, no hill, a level, empty table. What does the crank say it does?
The crank says the first law. No push, no change. It glides in a straight line at a steady speed. Left alone, it keeps doing what it's doing. That's the very first thing you ever taught me.
Now do it the new way. No landscape, no hill, so no place energy anywhere. The action is only ever the motion energy summed along the path. Ask which arc makes that flat, as small and even as it can go. Any arc that races ahead here and dawdles back there is burning extra motion energy it never needed, running the total up. The one that spends the least never changes its pace and never wanders off the line. Dead straight, dead steady, and not one push named anywhere in the getting of it.
Which is the first law all over again. The straight glide falls out of keep the action flat, and I never once said the word force. And if I put the hill back, a bit of gravity on the ball,
the flat path stops being a straight line and bends into exactly the arc you throw. The parabola, the very curve you saw hanging in the air at the start of the night. Same ball, same arc, whether you crank it forward tick by tick or hunt the flat path across the whole fan. To the last hair.
To the last hair. So it isn't a rival, it's not some different physics quarrelling with the old one and handing me different answers.
It hands you Newton's answers, the same arcs, the same ball in the same hand. Always. Same physics, walked in through a different door. One door starts with forces and grinds forward tick by tick. The other starts with a single number about the whole trip and asks for it to be flat. One clockwork, two keys.
And here's what catches in my chest. Remember my flag? The one I planted an hour ago? A path can't be chosen all at once. I stood on that. I was so sure.
You stood on it firmly. Go on then. Knock yourself off it.
If the flat whole path rule is the very same equation as the moment-by-moment crank, then I was right and wrong in the same breath. The ball never has to look ahead. It marches, tick by tick, exactly as I insisted it must. And the whole path story is dead accurate anyway. They're not two claims. They're one thing said two ways.
One thing, two ways. Make the whole journey flat and march the crank forward instant by instant are two sentences for the identical fact. So keep half your flag. The ball doesn't deliberate, doesn't peer into its future. And hand me the other half. It genuinely is describable as one whole path, chosen entire.
I somewhat resent how gently you took half the flag off me, but it's yours. So that's answer one. It gives the right arc because it is the crank in a disguise. Now, the second answer. Why carry the second key at all, if it only ever hands me back what I already had?
Because the crank, honest as it is, can be brutal. Think of the last time force made your life truly miserable. The moving thing wasn't flying free through open air. It was trapped on something. A bead threaded on a bent wire, forced to follow the wire's every twist. A weight swinging on the end of a stiff rod. The instant a thing is penned onto a track like that, the crank makes you bookkeep the track's own push.
Oh, I remember that misery from the force nights. The bead on the wire. You don't care about the wire, you care where the bead goes. But the wire is shoving on it sideways the whole time. And here's the cruelty. You don't even know how hard it's shoving until you've untangled the entire problem. You carry an unknown push through every single line of the working.
Bookkeeping for a force whose only purpose in life is to be in the way. So tell me, you want the flat spot door to let you skip it?
I want exactly that. Tell me that's the payoff. Tell me I don't have to drag the wire's push through pages of algebra ever again.
You don't. And not by magic, for a reason you can see with your own eyes. Here's the wire's push, and here's the one thing it never manages to do. It never does any work. Look at which way it points. The wire holds the bead onto the wire, so it shoves square across the bead's motion, dead perpendicular, sideways to wherever the bead is sliding. Always across, never along. And a push that is always square across the motion never speeds the bead up and never slows it down.
And work is a force pushing along the motion. Reaching out through a distance, the thing actually travels in the push's own direction. If the wire only ever shoves sideways, square across, then it's pushing through no distance in its own direction at all, so it does no work. It shoves and never adds a scrap of energy to the books.
Never adds a scrap. And now, watch it vanish. Our whole score, the Lagrangian, the action, is built out of energies, motion and place. The wire's push does no work, so it changes neither one. So it simply isn't in the number. You write your two energies, you never write the wire's push. Not because you cheated, but because a force that does no work adds nothing to the energy tally. It has no line in a ledger built of energies.
Let me make sure I feel the full cheek of this. That sideways wire push I once dragged through pages of algebra, I don't invite it. It never turns up to the party. I write my two energies, I hunt for the flat spot, and the wire's entire contribution to my evening is that it quietly told me which arcs were even allowed in the first place.
That's the whole of its job now. It draws the fences. It says which paths are on the wire and which aren't. It doesn't get to be a force anymore. It doesn't get an arrow.
So that is not beating the constraint force. That is declining to acknowledge it exists. You didn't win the fight, you refused to show up to it, and it turns out that counts as a win.
It counts as a win. And it gets better, because you also get to choose your own ruler. On the crank, you're stuck measuring in straight across and up and down, the honest square grid, because that's where the arrows live. But the flat spot rule does not care what numbers you use to say where the thing is. Take that weight swinging on the rod. The crank wants its height and its sideways place. Two readings, chained together by the rod, fighting each other every step.
Two numbers that aren't even free of each other. And what does the flat spot rule want instead?
The angle of the swing. One number. How far over it's tipped. Because the rod has already spoken for everything else. The bob can only ever be a rod's length from the pivot, so its whole freedom in the world is that single angle. Track the angle, and you've said everything there is to say.
So I write the pendulum's two energies in terms of that one angle. The motion energy of the swinging, the place energy of how high the bob has risen. Subtract them, sum along the swing, ask for flat, and out drops the pendulum.
The entire motion of it. And the rod's tension, the thing you'd have sweated over on a force night, resolving it into components, never written down. It does no work. It only holds the bob at arm's length, square across the swing. So it never entered. One angle, two energies, find the flat path. No free body diagram, no tension, no arrows.
So the pendulum, which on a force night was a little thicket of tension and gravity and components pulling every which way, becomes one angle and a subtraction. Look, no hands. I'll admit it, that's a properly satisfying trick. Same move as the wire, you pick a way of describing the swing where the tension has nothing to say, and so it says nothing.
Where the tension had nothing to say. Now picture something the crank truly dreads. Two rods, a pendulum hung off the end of another pendulum, the whole contraption flailing about. On the crank, that's a nightmare of tensions pulling on tensions. On this side of the room, it's two angles. The tilt of the first rod, the tilt of the second. Two numbers, two energies, find the flat path. The tensions never appear because they still do no work.
So that's why anyone carries the second key. Not because the crank is wrong, it's never wrong, but because the crank breaks its back on exactly the problems where this thing strolls. The uglier the pen the thing's trapped in, the more it saves you.
The uglier the pen, the bigger the mercy. Pick whatever numbers make the problem easy. An angle, 2 angles, a distance along a track, and every force whose only job was to hold the thing to its path pays you the same courtesy and vanishes from the books.
All right, I came in to call your bluff and I'm putting my hands up. It is not a bluff. You genuinely can do the whole of it with no forces. 2 energies, a subtraction, a long sum, and find the flat path. And where the crank sweats, this thing strolls. But there's a but loading up behind my teeth.
I can see it from here. Out with it.
You've answered the how so cleanly that the why underneath is screaming. None of this tells me why. Why would the world care about a flat total? Why should a ball give tuppence about keeping some sum of motion minus place as low as it'll go? Who told it to?
That's the question that ought to be screaming. Classically, staying inside the whole clockwork world we've built these 9 nights, I cannot tell you why. There's no deeper mechanical gear down there to point at. You take the true path makes the action stationary as a starting rule, a bedrock, the very same way we once took a thing left alone keeps gliding as bedrock and never asked it to justify itself. Every subject stands on a floor it doesn't dig beneath, a place where the honest answer is, because that's how the world turns out to be built, and everything true grows up out of it. Tonight's floor is the flat path.
So it's a postulate, a place you plant your boots and start walking, and you don't get to ask what's under the ground you're standing on.
Not at this level, no. It works. It reproduces every last thing, and inside classical physics, it simply is the rule. No why beneath it that I can hand you honestly.
That's oddly unsatisfying and oddly honest at the very same time. But you said classically. You said it with that lean you get. The same lean you had right before the merry-go-round turned into the whole spinning planet. There's a bigger room behind that word, isn't there?
There's a bigger room, and I'll crack the door. No more than crack it, mind, because walking all the way in is a whole other year of nights. Go back to your very first outrage, the one I told you to keep in your fist. The shopping, the ball trying every path and pocketing the bargain, the preposterous rock comparison shopping in mid-air. You made a whole joke of it, the pebble with a shopping list, checking every price before it deigns to fly.
That one. You made me feel a proper fool for it too. The man who thinks a stone does its accounts on the way across the room. I've been living that down all night, so go on, twist the knife. Tell me the stone really does keep books.
And here's the thing that ought to lift the hair on your arms. Down at the bottom of the world, where things are very small indeed, it is not absurd at all. It's near enough what happens.
Oh, come on. You're telling me the ridiculous thing I flung out as a joke, the ball actually shops? It genuinely tries every ludicrous loop and every scenic detour, all of them, and then settles the bill? You spent the whole night letting me feel like a fool for that picture, and now you're handing it back to me as the truth?
Handing it back with a twist that makes it stranger than your joke was. In the small world, the quantum world, and I want you to hear this as a doorway I'm cracking, not a thing I'm about to prove tonight. A particle really does, in a manner of speaking, set out along every path at once. All of them. The sensible arc and every mad detour, together, side by side.
All at once. So the other flag, the whole path chosen at once, the one you gently confiscated, down there it isn't even a figure of speech.
Down there it's nearer the plain truth than the crank is. And each path carries something with it. A kind of vote, if you like, with a timing set by that path's action. Here's the hinge of the whole thing. Where the action changes sharply from one path to its next-door neighbour, the 2 votes fall wildly out of step. Now line up all the wasteful, frantic paths. the loops, the detours. Out there in the wild, a hair's nudge of the path swings the action hugely, so every neighbour is badly out of step with the last. Vote cancels vote, up and down the whole crowd. A mob all shouting over one another, every voice killed by the one beside it, adding up to nothing at all. Silence.
A mob shouting itself into silence. So the loops and the scenic routes don't get vetoed one at a time, they drown each other out. Every crazy path has some equally crazy neighbour leaning the opposite way, and the pair of them wash to nothing. All across the fan, except, let me guess, near the sensible arc.
Near the flat spot. Near the stationary path, the action barely changes from one neighbour to the next. You told me that yourself. Flat means jiggling the path doesn't move its number. So right there, all the votes fall into step. Neighbour agrees with neighbour. They don't cancel, they pile onto each other and swell. A crowd that was pure babble everywhere else, suddenly all singing the one note.
And that swell is the path we actually see. The one note left ringing after everything else has shouted itself into silence.
The note left ringing. That's the survivor, and the survivor is the flat one.
So the reason the ball flies the flat path is that the flat path is the only place all these tried paths reinforce instead of murdering each other. It doesn't deliberate, it doesn't weigh, choose, shop. Everything else votes itself into silence. And the one arc left standing is the flat one. So the shopping was real after all. It just all cancels out, everywhere except at the bargain. My joke was right. I only had the mechanism wrong.
That's the doorway, and I'm going to close it gently now, before we tumble all the way through. Because the full machinery behind it is a heavy, glorious season all its own, and it lives in the small world, not in tonight's clockwork. Feynman's the name over that door, if you ever go looking for it.
But is it real, or is it a way of doing the sum? Because I can't tell, from where I'm sitting, whether the ball actually tries every path, or whether that's a clever trick for landing on the right answer.
A fair, hard question, and the answer is that in the small world, it is as real as anything we can test, and it is still a doorway I'm refusing to walk you through tonight. So carry only the shape of it out with you. The true path makes the action stationary, is not a mystical little preference the ball is nursing. It's the fingerprint, left in our big, slow world, of a small world where every path really is taken, and nearly all of them cancel.
So the universe is lazy and a show-off. It shows off, tries every path there is, the whole ludicrous fan of them, spares itself nothing. And then it's lazy, keeps only the cheapest, the flat one, and lets all its own extravagance cancel down to nothing. So that from up here it looks for all the world like it strolled one sensible line the entire time.
Extravagant underneath, thrifty on the surface. That's the temperament, near enough.
That has got a nerve, honestly. Trying everything, then keeping the bargain, and covering its tracks so cleanly that I spent 8 nights thinking a hand was pushing the thing across the room. And the real cheek of it is that both stories hold at once. There truly is no hand, and the flat arc truly hands me back every last force I thought I saw. I can't decide whether to be impressed or to feel a little swindled.
And notice, we made that whole climb without ever answering the classical why, because there is no classical why. The why lives downstairs, behind a door we only cracked. Up here in the clockwork, stationary action is simply a rule the world keeps. And by keeping it, the world is quietly keeping every one of Newton's books. Every orbit we drew, every pendulum, every top of this whole season, all of it sitting folded inside this one flat number, the way a whole melody sits inside a single held chord.
Then let me gather the whole night into my arms before you open any more doors, because something's rearranged itself right through me, and I want to see if I can hold it in one piece. Newton built the arc from underneath. Moment by moment, force by force, grind the crank, always local, always now. That was 8 nights of my life, and it was true, every tick. Tonight you climbed to a higher window and looked at the whole arc at once. No forces. 2 energies, motion and place, 2 plane sizes, not an arrow between them. Subtract one from the other, the minus that pays the ball to climb. Sum the difference the whole way along, and out of the entire ghostly fan, the world lights up the single arc where that sum sits flat. 8 nights I drew arrows. Tonight I drew none, and got back the very same world.
That's it, held whole. And the part that catches?
The part that catches is that those two aren't rivals. Grind the crank forward or hunt the flat path across the fan. They are the identical physics. The same arc, the same ball, the same waiting hand, down to the last hair. And where the crank made me sweat through a page of tensions, the flat path window doesn't invite the mess, because a force that does no work adds nothing to the energy tally, and so was never in the number. Same world, 2 doors, and behind the second door, a small world trying every path at once and cancelling all but the flat one. You've put a whole basement under the house I thought I knew.
So let me stand you in front of one more door before I go. Because everything you said tonight has a consequence we never once touched. And it's the one I'd most want you dreaming on.
Of course there's one more door. There is always one more door. You've never once let me leave through the same one I came in.
Look again at what we did tonight. We shrank all of mechanics down to a single thing. Not a thundering herd of forces, all pointing everywhere at once. One number about the whole journey, the action, and one rule about it. Make it flat.
One number and one demand in place of the whole herd. That's the compression that startled me most, if I'm honest. The entire subject, everything we've done, folds down into a sentence now. And you've got the door look on, so tell me, what does folding it into a sentence let me do?
It lets you ask a question you could never even phrase while the world was a mess of arrows. Ask this: what can I do to that one number without changing it? Slide the whole experiment 10 paces to the left. Does the action come out the same? Turn the whole apparatus to face a new direction. Same number? Run it today, run it tomorrow instead. Same number? These are the symmetries of the thing, the ways you can shove it, or spin it, or wait, and have the one number simply not notice you did.
The ways the world looks the same after you've moved it. Slide it over, turn it round, wait a day. All right, but that sounds almost like idle bookkeeping. Why would the world not noticing that I slid it sideways be worth a whole door? What could possibly hang on it?
Everything hangs on it. Here's the fact I'm going to leave you holding overnight, and it's the loveliest one we've reached in 9 nights. Every single one of those symmetries, every way the number refuses to flinch when you move the world, hands you, in exchange, a quantity that never changes as the world runs. Held fixed for all time. 1 for 1, a symmetry in, a conservation law out. And you already know one of the payouts in your bones. Run the world at a different hour. Today, tomorrow, it's all the same to the number. And out of that one indifference falls energy itself, that level line from the landscape night holding still for good. The world not caring what time it is simply is the conservation of energy, the very thing that's run under every night this season, a symmetry wearing a disguise the whole while.
Wait. Say that again because it sounds too neat to be allowed in a serious subject. The world not caring what hour I run it. That one little shrug quietly pays out the conservation of energy. The law I've leaned on all season was never a law in its own right, but the shadow of a symmetry.
The shadow of a symmetry. That's the very word. And energy is only the first of the payouts. Slide the world sideways instead of waiting on it, and a second conserved thing falls straight out. Turn it to face a new way, and a third. You've already met both, on other nights, thinking each was a law unto itself, and they never were. But I won't unwrap those two tonight. They're tomorrow's, and I want you walking in already half-guessing what they'll turn out to be.
So the whole reason to shrink mechanics down to one number wasn't tidiness. It was to have something you could take hold of and try to move. Because a single number is a thing you can slide or turn or wait out, and then ask, did it flinch? You could never ask that of 100 arrows all pointing every which way.
You couldn't even phrase it. A herd of forces has no single face to hold still. One number does. That's what makes the question askable at all, and the answer waiting on the far side of it is every conservation law in the book, handed to you free by the world's own indifference to being moved.
That's the sting in the tail, isn't it? So tonight wasn't really about ditching forces at all. That was the trick door, the one with the bright sign over it. Tonight was about getting the whole world down to a single number, so that tomorrow you can ask what leaves that number alone and catch every conservation law in the place falling straight out of the answer.
You see the whole shape of it. That's the series. Every door opens onto the next room, and the room you're in was built to point at it. So here's tomorrow's plainly. The symmetries of the action and the conserved quantities they've been guarding in secret. The deepest bridge in all of mechanics, straight across from the world looks the same if I move it to this quantity will never ever change.
You sly thing. You've been setting up the next night the entire length of this one, and that's for next time, I suppose.
That's for next time. Now, you know the ritual. You get the last word at the door. Hand me the image. What are you carrying out of this room?
The fan. That whole ghostly fan of arcs, every path the ball could ever have flown, hanging in the air over my living room, like tracings on tracing paper. The loops, the scenic routes over the mountains, the mad ones, and the sensible one, all of them there at once, every one a ghost, but a single one.
All at once. And the world?
And the world reaches in and lights up exactly one. Not by shoving it, not by planting a hand in its back and bending it moment to moment, but by some quieter, stranger arithmetic. Two energies, one subtracted from the other, summed the whole way along, and the single arc where that sum goes flat.
That's the one to keep. Hold it.
I'm holding it, because here's what changed in me tonight. For 8 nights I asked one question of everything that moved. What's pushing it? Where's the hand? Where's the arrow? Where's the force? And that question built me the whole world, and it was true every tick of it. And tonight you showed me the ball never needed a hand in its back at all. It just flies the flat path. Out of the whole hanging fan of everything it could have done, it quietly takes the one arc that makes the least fuss and lets every other ghost cancel away behind it. So the next time I watch anything cross a room, a ball, a planet, a swing, the whole tilted turning world, I'm not going to ask what's shoving it along. I'm going to ask the better question, the one you handed me tonight. Not what force is bending this path, but of all the paths it could have taken, why is this the one where the world went flat?